Hello there, and welcome back to this quiet corner of the universe, where curiosity slows down, and even the vastness of the cosmos feels soft enough to rest your thoughts on. Tonight, as you settle into whatever space holds you gently, I invite you to take a slow breath and another, and allow your mind to drift just a little beyond Earth, beyond everything familiar, and into a possibility that has always been waiting out there in the dark. We often think of Earth as perfect, the precious blue marble, the rare miracle, the only home where life could bloom the way it has. But what if Earth is not the peak of habitability? What if our world, beautiful as it is simply one version of life's story, and out there, in the soft glow of distant suns, there exist worlds even more nurturing than ours? Imagine this: planets where warmth wraps gently around entire continents, where oxygen is richer, vegetation more vibrant, water more abundant, and evolution more patient. Worlds orbiting calm, long-lived orange dwarf stars, suns that burn slower and steadier than ours, offering life not just billions, but tens of billions of years to grow, adapt, and flourish. On these worlds, life wouldn't need to rush. It wouldn't fear the sudden shifts, mass extinctions, or chaotic twists that have shaped Earth's history. Instead, it would unfold like a quiet symphony that never breaks, drifting through ages with a soft and steady rhythm. Scientists call them superhabitable planets. Planets not just capable of supporting life, but better suited for life than Earth. Some are slightly larger, with thicker atmospheres that hold warmth and protect their surfaces for eons. Others are older, giving evolution billions of extra years to sculpt breathtaking ecosystems we can barely imagine. Many orbit stars much calmer than our sun, bathed in golden light that feels almost eternal. Tonight, we're going to drift through these worlds together. Worlds like Kepler 442b, GJ 251c, Proxima Centauri b, places where oceans may steam gently beneath soft alien skies, where forests breathe more deeply, and where life, if it exists, may have had far more time than we have to create complexity, beauty, and intelligence. You don't need to hold on to these ideas. Just let them float past you, like stardust carried on a slow solar wind. With each breath, imagine yourself drifting farther from Earth's gravity and closer to these quiet, warm, superhabitable havens scattered throughout the galaxy. If the universe is a vast garden, then perhaps Earth is not the rarest flower, only one blossom among billions. And somewhere out there, life might already be thriving in richer soil, under softer light, in worlds that make our home feel wonderfully humble. So, whenever you're ready, let's begin this gentle journey to the planets that could surpass our own, worlds that whisper, life can be even more extraordinary than we believed. Chapter 1. When Earth stops being the standard. Take a slow breath in, and as you exhale, imagine the gentle sound of starlight. No rush, no pressure, just a soft shimmer drifting across the darkness. Tonight's journey begins with a quiet question, one that seems almost rebellious at first. What if Earth is not the best home for life? For thousands of years, our ancestors looked at the night sky and dreamed of other Earths, worlds that might mirror our oceans, our breezes, our delicate balance of warmth and cold. We imagined twins of our blue planet, orbiting suns like ours, shining with familiar golden fire. But in recent decades, as our telescopes sharpened and our understanding deepened, something surprising began to emerge. Earth, as wonderful and precious as it is, might not be the pinnacle of habitability, only a decent attempt. Scientists once believed life needed a planet exactly like ours, same size, same atmosphere, same distance from the star. Life, they thought, thrives under a narrow set of conditions, the Goldilocks zone. But as we discovered thousands of exoplanets scattered across the galaxy, patterns emerged that whispered a different truth. Earth has endured chaos, mass extinctions, sudden climate swings, asteroid impacts, volcanic winters, and moments when life nearly vanished. In cosmic terms, Earth is not stable. It is resilient, yes, but fragile. Its habitability rises and falls like a slow-breathing cycle. So astronomers asked a new question. If you were designing a planet for life, not just survival, but abundance, what would it look like? The answers that emerged were astonishing. A superhabitable planet, they found, would likely be slightly larger than Earth, giving it a stronger grip on its atmosphere. It would orbit a long-lived, peaceful orange dwarf star, a sun that glows softer and steadier than ours for tens of billions of years. Its temperature would be a touch warmer, its air a little richer in oxygen, its oceans deeper, its continents arranged in patterns that create endless coastlines and gentle climates. A world like that wouldn't just support life, it would supercharge it. More forests, more ecosystems, more stability, more time. And suddenly, Earth, our beloved, imperfect home, became not the standard, but just one example among many possibilities. Tonight, we drift into those possibilities, worlds where life doesn't just survive the universe, but flourishes beneath it. Take one more slow breath, and let's float gently to our next chapter, where we step onto these worlds for the first time and see what life might look like where nature perfected the recipe. Chapter 2: The Anatomy of a Superhabitable World. Close your eyes for a moment and picture a sunrise, but not an earthly one. Imagine light that isn't the fierce white-yellow of our sun, but a deeper, softer amber, a glow that feels warm, patient, and endlessly calm. This is the light of a K-type orange dwarf star, the kind of star most superhabitable planets call home. They burn slower, they flare less, they live 3, 4, even 5 times longer than our Sunday. Life here has time, long, uninterrupted time. As the light pours across the horizon of a superhabitable world, you begin to notice its details. The planet beneath your feet is slightly larger than Earth, perhaps 10% to 20% bigger in radius. The ground feels familiar, but the gravity holds you just a little more firmly, like a reassuring hand resting on your shoulder. This stronger gravity helps the planet hold onto its atmosphere for billions of years longer than Earth can. And what an atmosphere it is. Instead of 21% oxygen, the air holds 25% oxygen, a quiet but profound difference. Plants breathe easier, ecosystems grow denser, animals evolve with more energy. Everything feels more alive, more vibrant, more efficient. The temperature? Just 5 degrees Celsius warmer on average. It doesn't sound like much, but it transforms everything. The polar ice caps shrink into delicate crowns. Humidity rises. Rainforests stretch farther. Seasons soften into smooth gradients rather than sharp contrasts. Clouds drift slowly across the sky, thick and nurturing, reflecting sunlight and stabilizing climate. These clouds are not violent, not storm-heavy. They are the lungs of a mature, balanced world. Look closer and you'll see active plate tectonics, older and more persistent than Earth's. Mountain ranges flow across the landscape like slow waves frozen in stone. Volcanoes enrich the soil with nutrients. Rivers carve fertile valleys that might support ecosystems unimaginably diverse. And the oceans, deeper, richer, stirred by multiple moons tugging at their tides in gentle, complex rhythms. These are not chaotic worlds. They are well-tuned, worlds sculpted not by random accidents, but by long cosmic patience. Every feature, the warmth, the moisture, the oxygen, the star forms a symphony tuned precisely to life's comfort. If Earth is a garden growing beautifully in unpredictable weather, a superhabitable planet is an ancient forest that has perfected its balance over billions of years. Now take another slow breath as we drift onward, because in the next chapter we leave theory behind and step onto real worlds scientists have already found. Chapter 3: The Real Places That Outshine Earth. Let your thoughts drift now from imagination to reality, because some of the worlds scientists have discovered aren't dreams. They exist. They orbit their stars at this very moment, billions or mere dozens of light years away, quietly shining with the potential for life richer than our own. The first is Kepler 442b, about 1,200 light years away. On the new planetary habitability index, Earth scores 0.829. Kepler 442b scores 0.836. A small difference in numbers, a vast difference in meaning. It orbits an orange dwarf star, right in the sweet spot for liquid water, slightly larger than Earth, potentially older, possibly home to ecosystems that have had far more time to evolve. Then there's GJ 251c, just 20 light years away, a cosmic neighbor. This world is nearly 4 times Earth's mass, with the ingredients of a rocky planet and the potential for deep oceans warmed by a calm red dwarf star. It could host stable climates for tens of billions of years, longer than Earth will ever experience. And then there is Proxima Centauri b, only 4.2 light years away. If we could visit any superhabitable candidate within a single human lifetime, it might be this one. Proxima b receives about 65% as much light as Earth does from the Sun, just enough to maintain liquid water, perhaps vast oceans. If it retained its atmosphere, it may be a sanctuary of life. Next is TRAPPIST 1e, part of a family of 7 Earth-sized planets. Up to 4 lie within the habitable zone. Imagine an entire solar system where multiple worlds could support life, where ecosystems might evolve in parallel, exchanging biological material through meteors and impacts. Finally, there is GJ12b, an Earth-sized world just 40 light years away, with temperatures near 42 degrees Celsius, warm, tropical, and potentially drenched in oceans wrapped in humid atmospheres. These planets are not theoretical perfection. They are real possibilities, quiet, distant invitations. As we drift deeper into the journey ahead, we'll explore how scientists find these worlds, how they read their atmospheres from light years away, and what it truly means if Earth is not the best place for life, only one of many. But for now, let your breath soften. Let your mind drift lightly between these stars, because our journey has only just begun. Chapter 4: A star that lives long enough for life to perfect itself. As we drift farther from Earth's familiar sunlight, let your imagination float into a softer glow, a light deeper, warmer, steadier, the light of an orange dwarf star, the quiet beating heart of almost every superhabitable world. Stars like our Sun live for about 10 billion years, long on human scales, brief on cosmic ones. But orange dwarfs, they burn slowly, patiently, not in a rush to consume their fuel, not prone to violent flares or dramatic tempers. Their lifespans stretch from 20 to 40 billion years, 4 times the lifespan of our Sunday. Imagine life evolving under that kind of patience. On Earth, evolution has been interrupted over and over again. Asteroid impacts, volcanic winters, mass extinctions, climate swings violent enough to erase entire branches of life's family tree. But under the gentle glow of an orange dwarf star, evolution would have unbroken time, billions upon billions of years of warm stability. Life could grow slowly, but deeply. Creatures could adapt not in frantic survival, but in soft experimentation. This kind of star produces less ultraviolet radiation, the type that can damage DNA, just enough UV to drive chemistry, not so much that life must hide underground or underwater. If life on Earth is a story written under pressure, life on a superhabitable world is a story written in calm daylight. Picture standing on the surface of such a planet. The sunlight feels slightly more golden, almost honey-colored, the shadows softer, the sky warmer in tone. Everything grows under patience. Forests breathe steadily. Storms are gentler. The climate changes slowly, like deep inhalations and exhalations instead of violent spasms. And because the star changes brightness only very gradually over eons, the planet stays in its habitable zone for a very long time. A world with that much stability isn't just habitable. It becomes a cradle, a nurturing womb that could raise life to heights we can barely imagine. As you breathe slowly, imagine that gentle amber light touching oceans, mountains, and perhaps entire civilizations shaped by a star that never hurries. Now, let's drift deeper into the planet itself, because the secret of superhabitable worlds is not only in their stars, but in the world's own bodies. Chapter 5. When a planet's heart beats longer than Earth's. Take a slow breath and imagine a planet's geology not as cold stone, but as a living heartbeat, pulsing heat, moving continents, stirring oceans, feeding life. Earth's interior is slowly cooling. One day, far in the future, our tectonic plates will freeze. The recycling of nutrients will stop. The atmosphere will thin. Life will struggle. But superhabitable planets, they are often larger, 10 to 50% more massive than Earth. This small difference means a tremendous change in the way they live. A larger planet holds more radioactive material deep inside. This material decays gently, like embers glowing in a fire pit. And that slow decay powers plate tectonics for tens of billions of years, long after Earth's geology goes silent. Imagine walking on such a world. Mountains rise slowly, gracefully, like wrinkles on an ancient, thoughtful face. Volcanoes enrich the soil with nutrients essential for thriving ecosystems. Rivers carve valleys over immense spans of time, nurturing habitats that never disappear abruptly. These planets don't experience the violent resets that Earth does. No sudden ice ages triggered by massive eruptions. No extreme basins drying out. No supervolcano darkening the skies for decades. Instead, the planet breathes slowly. Its continents drift in long, gentle arcs. Its climate shifts like the turning of pages in a very old book. And there's something else, something subtle but powerful. A planet with stronger gravity keeps its atmosphere better. Earth's atmosphere is thin, fragile, easily stripped by solar wind over billions of years. But a superhabitable world clings to its atmosphere tightly. This means denser air, better protection from radiation, stronger greenhouse balance, more humidity, richer oxygen cycling, larger and more active ecosystems. Picture forests with leaves thicker and greener, animals with deeper lungs, stronger bodies, oceans rich with nutrients stirred by complex tides from multiple moons. Everything is more, not harsher but fuller, more stable, more generous. The geology of a superhabitable world is not a hazard, it is a life giver, whispering nutrients into oceans and continents with infinite patience. Now take another soft breath, because next we drift into something far more mysterious, what life itself could become when given billions of extra years in perfect conditions. Chapter 6. Life in a Universe Built for Flourishing. Close your eyes, if you'd like, and imagine a rainforest not on Earth, but on a world older, warmer, and richer. A planet where evolution has had twice as much time to create, refine, and perfect the art of life. Earth's story has been chaotic. 4 billion years of progress interrupted by disaster, 5 mass extinctions, endless climate swings, life constantly reset, forced to begin again. But on a superhabitable world older by billions of years, stable for unimaginable spans, evolution becomes something else entirely. It becomes unbroken. Imagine forests so lush they stretch from the equator to the poles, oceans teeming with life at levels Earth never achieved, creatures with metabolisms shaped by rich oxygen and constant warmth, plant life optimized by billions of sunlight-filled years under a gentle star. Maybe these worlds host megaforests breathing in perfect rhythms, oceans with nutrient cycles so efficient they never collapse, ecosystems so dense each square kilometer holds thousands of species, insects with wings shimmering with colors Earth never produced, coral-like structures spanning entire coastlines, and intelligence, if it arises, would have billions of years to deepen, not pressured by extinction, not forced to restart, but allowed to grow slowly, reflectively, like a mind shaped by patience itself. Imagine beings whose evolution has unfolded in calm, creatures that live long, think slowly, and understand their world in ways we can't yet imagine. Societies with time, real time, to master harmony rather than conflict. Maybe their technology is indistinguishable from biology. Maybe their communication is woven into planetary cycles. Maybe their consciousness stretches across forests, oceans, or even magnetic fields. Life here isn't rare or lucky. It's inevitable, a natural flowering under perfect conditions. And as you breathe softly, imagine this final thought. If Earth produced us under chaos, under stress, under the weight of countless setbacks, then what could life become on a world built for flourishing? Chapter 7. How we discover worlds we cannot touch. Take a slow breath and imagine you're standing in front of a telescope, not one made of brass and glass, but one made of light itself. Because in reality, every exoplanet we know, we found through light, shadow, and patience. No spacecraft has ever visited Kepler 442b, or Proxima b, or TRAPPIST 1e. We have never seen a tree there, or a cloud, or an ocean wave, and yet we know these worlds exist. We know their sizes, we know their orbits, we even know hints of their atmospheres. How? Through methods as gentle and precise as a heartbeat monitor. The first is transit photometry. Imagine watching a star twinkle. Now imagine something tiny passing in front of it, too small to see, but large enough to dim the star by the smallest fraction of a percent. That dip, that soft, imperceptible flicker, is a planet. Every time its orbit carries it across the star's face, the light dips again, a perfect rhythm, a cosmic pulse. From these tiny flickers, we learn the planet's size, the length of its year, the shape of its orbit, even hints about its atmosphere. The second method is radial velocity. Stars wobble not because they are unstable, but because planets tug on them, small gravitational nudges. As a planet orbits, its star wobbles toward us, then away. These motions shift the star's color ever so slightly, like breathing in and out. From that wobble, scientists can measure the planet's mass, its density, whether it is rocky like Earth or gaseous like Neptune. Then there is atmospheric spectroscopy, perhaps the most magical of all. When a planet passes in front of its star, starlight filters through its atmosphere. The atmosphere imprints its chemical signature into the light, tiny fingerprints of water vapor, oxygen, methane, carbon dioxide, biosignature gases. This means we can read a world from trillions of kilometers away simply by analyzing light. And so, through flickers, wobbles, and color shifts, we map the invisible. We find oceans without seeing water. We detect air without feeling wind. We sense life without hearing its heartbeat. All from right here on our tiny world. Take one more soft breath, because next we drift into something even gentler. How these worlds might feel, not just scientifically, but emotionally, if we ever stood on their surfaces. Chapter 8. Standing on a world kinder than Earth. Imagine, for a moment, that you are standing barefoot on the soil of a superhabitable world. The ground beneath you is warm, not hot, not harsh, but softly heated by a star that glows like melted amber. The gravity presses gently against your feet, a touch stronger than Earth's, grounding you, steadying you. You take a breath. The air feels different, fuller, richer, smoother. It contains more oxygen, and your lungs react with a kind of ease you've never felt before. The sky overhead is a deeper color, not blue, but a warm gradient between honey and pale gold. Clouds drift slowly, thick and nurturing, like enormous blankets of moisture spreading even warmth across the planet. You begin to walk. The landscape flows in gentle curves, no extreme mountains, no deep, harsh canyons, just ancient geological forms shaped by billions of years of peaceful tectonics. Forests rise in the distance, not dark green, but a brighter hue, fed by dense nutrients and an atmosphere optimized for photosynthesis. Plants tower higher, leaves are broader. The air smells of life, wet soil, warm vegetation, subtle floral notes carried by slow winds. A river flows nearby. Its water is impossibly clear, stirred by tidal rhythms from multiple moons, gleaming faintly in the sky. The river carries nutrients with perfect efficiency, as if the entire planet is designed to recycle life endlessly. As you walk along the shore, you notice creatures small, shimmering, moving with elegant fluidity. Their bodies look familiar and strange all at once. Shapes evolved in a world without mass extinctions, without sudden collapses, without evolutionary resets. Creatures shaped by continuity. You realize something profound. On this world, ecosystems are complete. No broken webs, no missing links, no scars of sudden endings. Life has never been interrupted. It has been allowed to paint its masterpiece through billions of years of uninterrupted creativity. And in that moment, as a soft wind touches your skin, you understand. Earth is beautiful, Earth is home, but this world is ideal. Take another breath, feeling the warmth of this imagined place. Now we drift into a deeper question, the one scientists whisper about behind closed doors. Could the life on these worlds be older, wiser, and far more advanced than us? Chapter 9. If life has billions of extra years, what does it become? Let your breath soften, because now we step into one of the most humbling ideas in all of astronomy. Earth is about 4.5 billion years old. Complex life appeared only 600 million years ago. Intelligence, human intelligence, barely a blink in cosmic time. But superhabitable worlds, they might be 6, 7, even 8 billion years old, older, calmer, more stable. That means life there has had billions of extra years to evolve. What happens to evolution when it is uninterrupted? What happens to intelligence when it is given not thousands of years, but millions or billions? Imagine beings shaped by stability, not catastrophe, creatures who grow in harmony, not competition, species that never endured mass extinctions, never had to restart, never lived on the brink. Their intelligence may not be like ours, rapid, anxious, inventive, out of necessity. Theirs might be slow, deep, reflective, a wisdom evolved under kinder skies. Perhaps they developed biological technology integrated seamlessly with ecosystems, atmospheric engineering that maintains perfect climate, oceanic communication networks, neural systems that extend between individuals, forming collective minds. Their civilizations might not build metal towers or noisy machines. They may shape forests the way we shape cities. They may engineer rivers the way we engineer roads. They may manipulate the chemistry of the atmosphere like an artist painting with air. Such beings might communicate through light emitted from bioluminescent skin, magnetic field modulations, vibrations carried through planetary crust, synchronized biological rhythms. Their science would not be based on conquering nature, but understanding it so deeply that the line between organism and environment disappears. Perhaps their greatest achievement is not space travel, or technology, or conquest, but perfect planetary harmony, something humanity has barely begun to imagine. And if we ever detect such worlds, we may not find cities or machines. We may find something quieter, more subtle, more elegant, a planet that is too perfectly tuned to be natural, a biosphere that reflects intention, an atmosphere balanced with precision, a world that whispers, "Someone lives here, and they have lived well." Chapter 10. The silent signals of life across light years. As we float deeper into this quiet universe, imagine something subtle, a whisper, not of sound, but of chemistry. Because if life exists on superhabitable worlds, it might not communicate with radios or lasers, but with air. You see, an atmosphere is more than a blanket of gas. It is a living diary. It records every breath of every ecosystem, every chemical exhale, every sunrise-driven reaction, and the atmospheres of superhabitable worlds, if life thrives there, might glow with signs far louder, far clearer than anything Earth ever produced. Scientists call them biosignatures, but the term hardly captures the poetry behind them. Imagine oxygen levels far richer than Earth's, methane and oxygen coexisting, impossible without life. Water vapor thick enough to sustain global forests. Dimethyl sulfide, produced by oceans full of microorganisms. Seasonal rhythms in carbon dioxide that pulse with plant life. On Earth, these signatures are faint, subtle, easily drowned out by geological noise. But on a superhabitable world, life would be abundant, not struggling. Its atmospheric fingerprints might blaze across space like lighthouses. Through telescopes like the James Webb, scientists already sense whispers in the light, patterns that suggest dense atmospheres, active chemistry, oceans evaporating and condensing. gases that shouldn't exist without something alive and thriving. But perhaps the most extraordinary possibility is this: advanced civilizations, ones with millions or billions of years of stability behind them, might tune their atmospheres deliberately, not for industry, not for power, but for balance. Imagine a world where greenhouse gases are perfectly regulated, oxygen is precisely calibrated, weather patterns are controlled through bioengineered forests, entire ecosystems function like a symphony. Such atmospheric perfection might be the real sign of intelligence, not noise, not pollution, but harmony so exact that it could not have arisen by chance. If Earth is a messy sketch, these worlds may be finished paintings, signed not with metal and machines, but with biospheres tuned to sustain life indefinitely. Take a slow breath, because next we go deeper into the hearts of worlds, shaped not only by biology, but by the powerful physics beneath their oceans and crust. Chapter 11: Oceans that never tire, continents that never rest. Imagine a world where the ocean breathes with more rhythm than Earth's tides, not the simple tug of one moon, but the complex dance of 2, 3, maybe 4 moons, each pulling gently on the waters. The result is mesmerizing: deeper mixing, richer nutrients, constant currents, ecosystems fed from every direction. On Earth, nutrient upwelling happens in narrow regions, but on a superhabitable world, tides become a global orchestra, lifting nutrients from the deep sea and spreading life across every coastline. Now imagine the continents. On Earth, plate tectonics will stop one day, our planet cooling slowly, its heart dimming. When that day comes, Earth will be geologically still, and biological life will slowly follow. But on a larger, warmer, superhabitable world, tectonics might last tens of billions of years. Imagine continents drifting so slowly and smoothly you could watch mountains grow like slow foam pushed from below. This geological longevity means constant recycling of nutrients, endlessly renewed soil, stable climates, continents shaped into optimal patterns by eons of movement. Picture continents arranged not chaotically, like Earth's, but naturally sculpted into forms that maximize habitability. Broad coasts, gentle inland seas, mountain ranges positioned to distribute rainfall evenly, valleys rich enough to support life everywhere, and overhead, moonlight glows softly on tidal estuaries, not harsh, not lonely, but warm and inviting, as if the night itself has learned to nurture life. But beneath all this beauty, something extraordinary stirs: the possibility of biological and geological cycles so intertwined that the entire planet behaves like a single living organism. Forests breathe, oceans mix, continents drift, and the atmosphere adjusts in response. All coordinated, all balanced, a planet that doesn't merely host life, but is alive in its own way. Take another soft breath, because in our final chapter, we return to the question that started this journey. If Earth is not the best world for life, then what does that mean for us? Chapter 12: The gentle realization that we are not the standard. As the journey reaches its quiet end, imagine yourself floating above Earth, not judging it, not criticizing it, just observing it with soft, grateful eyes. Our world is beautiful, but it is also precarious. Life here has fought for every inch of progress. Mass extinctions, firestorms, ice ages, meteor impacts, volcanic winters, sudden shifts that erased entire futures before they began. Earth is not a perfect cradle. It is a survivor's cradle, but superhabitable worlds. They remind us of something profound. Life need not be rare, nor fragile, nor clinging to existence. Life, given the right world, might flourish with ease, might bloom endlessly, might reach heights we cannot yet imagine. And here is the quiet truth. If Earth is not the best home for life, then life itself may be more common than we ever dared to hope. Perhaps the universe is not a cold void with scattered oases, but a vast garden where worlds beyond number drape themselves in forests, oceans, winds, and consciousness. And so we end where we began, with breath. Inhale gently and exhale slowly. Earth is our home, but it is one home among many possibilities, not the grand climax of biology, but one chapter in an infinite cosmic library. Somewhere out there, under an amber sun, on a world older and richer than ours, life may already be thriving, growing, evolving, thinking, waiting, not dangerously, not competitively, but peacefully, as if the universe built a better version of Earth and let it live out the life our planet never could. And perhaps one night, when our telescopes grow wise enough, we'll finally see it, not with fear, but with wonder, and with the soft, humble realization that life does not end with us. It begins everywhere,